Okay, welcome everyone. This talk is the new alchemy, turning data into the gold, but you already knew that. That's why you came, I hope. My name is Brian Johnson. I'm part of the search organization at eBay. So I work on synonyms, acronyms, related searches, spelling, and they're all driven off of data mining. So I'm going to start just by telling a little bit of a story about how shopping is moved from offline to online, and the kind of things that are possible to do now online that you couldn't do in the past. So when you walk into the grocery store, the store doesn't always know that you walked in, and they might not know they don't know what you're doing as you walk through the store. So when I walk up to a shelf and I pick up an item in the store and I look at it, if I pick up a can of soup and then I put it back down and then I pick up the can of soup next to it and I decide to buy one of those, nobody knows that information. But online, you do have that information. So you can see what people look at and what they put back before they buy it. So the stores also have done market basket analysis. So when you check out, the grocery store knows what you bought. They know how their inventory is turning over, what people are buying, but they don't necessarily know the items that you picked up and looked. Well, not that they don't necessarily know. They don't know the items that you picked up and put back and didn't buy. They don't track you as you walk through the store. When you're in an online store, you're tracked as you walk through the store. People know when you walked in the store. They know which aisles you go down. They know which things you're going to look at. I just put on blank on purpose. I'll blank it in a second. So I just wanted to start with a bit of a story about the kind of data that we have available online. So as you walk around, people in an online store, you can keep track of what people look at and the things that they pick up and don't buy and put back. And just as importantly, in an online store, you can keep track of the things that people walked by, even if they didn't touch them, right? So in the business that I'm in search, we keep track of course, we log every page view, like all of you do if you're running an online business. But we also keep track of the items that you click on, we keep track of, and those show up as regular page views and log. We also log all of the item IDs for the items that people didn't look at. So every time you do a search on eBay, we log all the item IDs for all the items on the page, whether you clicked on them or not. And that's incredibly valuable for us when we go back and do analysis later, because if you clicked on the 9th item down, we want to know what were the first 8 items that you skipped over, and we want to figure out why you skipped those items. And if you're running a store, or if you're running a small business and you're partnering with somebody who's doing your statistics for you, that kind of information is really valuable. So I just wanted to start out with a little bit of a story about kind of some of the differences between online and offline. I know you should all be familiar with that. So I work in eBay. So eBay, we sell a lot of things in a lot of different categories. I know some of you here have a lot of different things on eBay. I was talking to the Toad and Frog folks, I guess, today. They're doing trading cards on eBay. Here they are right here in the front. And it's a long tail, right? There's a lot of trading cards. They have a lot of different things. So they're selling in probably a few different categories. But online, there's a lot of inventory, and you have to manage a lot of inventory. So for these guys, a big deal is keeping track of prices. Prices change over time. They can be dynamic. There's a lot you can do mining your own data to keep track of those things. And the talk today is a little bit about big data, but I'm going to talk about that in just a second. This is kind of some of the things that eBay does. This isn't a website. This is just from an analytics standpoint. What's the data that we log from an analytics standpoint? How do we turn it over, and where does it go? And a lot of the numbers are pretty big, and I'm going to talk about that a little bit on the next slide. But it really doesn't make any difference. You hear people talk about big data all the time, and a lot of times they're talking about data mining, and I'm going to talk about Hadoop in a little bit and how we do some of those things. But I think big is not what's important to you guys. Some of you are smaller merchants. Big really depends on the size of your website and how much traffic you have and how many users you have. What's really important is detailed data analysis. So what many of you have been doing in the past, and what I did in the past and many other businesses did in the past, was aggregate data analysis. So you would say, if you were in the data analytic part of your company, you would go out to the business folks and say, what are the questions that you guys need to have answered? And then you would build a system that would answer those questions. And you would put your data into a relational database, or you might put it into a large data warehouse. eBay's got one of the biggest Teradata installations in the world. So we have an enormous Teradata warehouse. And then you can run reports, and you can do all your business reports on that data, and that's incredibly valuable. What you miss there is the questions that people haven't asked yet. So you can design for the known. That's actually easy now, to design for the known. It's designed for the unknown. That's the hard thing, right? What are all the questions that people have not asked yet? So when you run your business, the things that were the same yesterday and the day before and last year, you probably got those all figured out, right? It's the new things that you're going to be interested in. So what happened yesterday, or how did things change? And then you have a new question. You're like, oh, something changed in my business, and I want to ask a question about that. And you want to turn those questions around relatively quickly. And if you're doing aggregate analysis and then feeding things into a relational database and then building canned reports off of that, when things change, it takes you time to do that. So if you are an analytics environment where it took you 6 months to build new reports or 3 months to build new reports, those kind of things can lag, and you're not going to be serving your business. So some of you are at companies maybe like Visistat, where you're doing the analytics and you're providing that as a service to other folks. Or some of you are at small businesses and you're going to be asking your service providers. These are the kind of questions I would like to have asked. So a lot of the questions you're going to have for your business, you don't know yet, and you're going to ask those in the future. And in the past, you couldn't do these kinds of things. It was just prohibitively expensive. So another thing to think about is, why is big data a big deal now? Like, why is it a big deal today? And I'm not sure if I got my slides in the right order. No, it's coming up in a couple seconds. But the real question, the answer to that is, it's cheap. It's always been an incredibly valuable thing to do. It's just, in the past, the cost of doing it was higher than the value. And now it's not. The cost is lower than the value. So there's a return on investment, so everybody's going to do it. And when you talk about big data, you'll hear people typically talk about volume. Because people like to, when you're going to talk about, people don't talk about detailed data analysis. They usually talk about big data. It's a big data talk, or this guy's doing big data analysis. And big data usually means detail. So people talk about volume, but volume is not the only thing. So it's how much data are you going to store. And you hear people start talking about big numbers, but that just depends on the size of your business and how many users you have coming through, how many transactions you have. In a smaller company, it's going to be smaller. Volume is only one piece of it. A lot of people say 3 V's. So there's volume, and the second is velocity. And this has been changing a lot. I mean, things are continuing to accelerate from a technology standpoint. You've heard that at this conference from many different people, and the trend is going to continue. If you think back 20 years ago, how did things look? People didn't have cell phones, right? There weren't all these mobile devices generating data. People were the same. Restaurants looked the same. Cars looked mostly the same. Computers were completely different, right? People weren't really connected to the internet 20 years ago. So, I mean, it's not, 20 years isn't that long, right? In the past 2 decades, it's changed a lot. And it's not slowing down. It's speeding up. I guess recently there was, the Nobel Prizes were awarded, and there was a counterintuitive, one of them was counterintuitive, that the universe is not only expanding, but it's expanding faster all the time, which I don't quite understand. I'm not a physicist, I guess, exactly how it is that this dark matter is making things expand faster. I don't know if you have dark matter in your businesses, but something is making things change even faster every day. And it's really because we're building on top of the past, right? Every day we can build on what was there yesterday, and that gives us more leverage to build the next generation. And then the last, I think, is the most important, which is the types of data, the variety of the data that you're storing. So for the canned aggregate reports, you had very structured data. You asked the questions, you stored your data, you knew what you were going to store, you got reports, you had a dashboard every day, you knew what you had. So what people are moving into now with detailed data analysis is you could ask a lot of different kinds of questions. You don't always know what they're going to be, and you can't pre-can all of your aggregate reports to answer those questions. You're going to have to go back to your base level log file data, right, your web logs, and look at what people have done. Or look at, on eBay, we're going to have to go back and look at the item inventory, look at the web logs, and figure out how to answer a new question. So you don't want to throw that data away anymore, and you don't have to. So this is the value over cost slide. So why now? And it really is, it's just simple. It's just return on investment. You can buy 2 terabyte drives now for about $80. I think I can't remember if I got it off by an order of magnitude, 4 or 40 cents per gigabyte. The space is cheap now. You can store all this data on spinning disks now, which you couldn't do in the past. In the past, people would archive this data to tape. But they'd either archive their data to tape or they'd roll their logs over. Most people would roll their logs over. But when you roll your logs over, you save your logs for 90 days, and then you throw them away. You're throwing that data away. So if you were in business, that's kind of the title, come back to the title of the talk, turning data into gold. You wouldn't, if you had cash, you wouldn't burn it or throw it away unless you were really rich. And if we were that rich, we probably wouldn't. None of us would be here. So you don't want to throw it away if there's value in it. Okay. And so what do people do with this data when it grows this quickly? So Moore's law is telling us that processor density, processing speed is doubling about every month, every 18 months. And how fast is data doubling? You get different answers if you check different sources, but I think there's kind of basic consensus that data is growing at least as fast as processing power, probably faster, right? It's probably growing faster. So if data volumes are growing faster than processing power, what does that mean? Like, how does that change the way that you run the business? And what it means is, instead of pulling your data to your processing power, instead of pulling cartloads of data to me, you're going to send your processing to your data. And that's where things are moving. That's where things are moving now. So it means you want to land your data one time, typically, right? You don't want your data scattered all over the place, and you want to pull it in when you want to analyze it. You're going to want to bring that data into your company, and then you're going to want to land it once or twice. You don't want to copy it all over the place because it's quite large. And then you're going to want to do your processing there. And I'm going to talk about this a little bit in a minute, but we have an enormous Teradata installation at eBay for data warehousing, which we've had for many, many years. But what's changed in the last few years is Hadoop, these sort of parallel processing disk farms. So how many people here are familiar with Hadoop? Okay, it's like half of you, some of you. So the easy way to think of Hadoop for those of you who aren't familiar with it is if I had an enormous server farm. Everybody thinks of server farms like these big football fields, type things. Just think of spinning arrays of disks, and on top of every disk, there's a processor. That's kind of how it is. You've got a server farm. It's got a lot of times the servers now have 12 terabytes of space in them, and you'll have multiple cores for processing. Think of it as a disk stack with a CPU on top of it. So when I have a question, I say, I want to look at everything that Brian Johnson has done in the last year, and I want to do a lifetime customer value analysis on Brian Johnson. You send that request out. It goes to all the disks in the entire farm, and every one of those CPUs runs through its disk stack really quickly, and it pulls out all the threads that include Brian Johnson, right? That have my user ID. It pulls them out, and then it sends them back, and you pull that data back, and then you process it. So the paradigm is called map-reduce programming. So the mapper is the part that goes out and fetches all the data and projects it out, and then it comes back. And then the reduce is, now I take each customer and I run through that customer. And we can do that in parallel now for every single customer, right? eBay's got 97 million customers, and we can do it for all of them now because we have these enormous disk farms. And one of the things I thought was interesting, I thought I'd just highlight that one slide about data growth, is people are always talking, there's always a new buzzword, and you don't really have to care about volume, I was telling you. I wouldn't worry about it too much, but zettabytes. So how much data is in the world? 1.2 zettabytes. And I thought the interesting thing about this slide is how many grains of sand there are in the world. And it's 0.0075. So we're talking about more bytes of data than we have grains of sand in the world, which I just thought was kind of an interesting aside. It's always, when I worked at Synopsys years ago in the chip design business, when I first started, I thought it was really interesting to find out that how far does light travel in 1 nanosecond, which actually mattered in that business. And it was the length of one long neck beer bottle, and I never forgot it. Because it's kind of catchy. Oh, it's the length of a beer bottle. That's great. And so you're going to collect, if you're collecting this data, you want to do it so you can change your business faster and impact your business. So if you have a lot of data, there's all kinds of interesting questions you could ask. And there's all kinds of interesting questions that you could answer. And sometimes people will go and answer the questions. It's kind of like the joke with somebody that drops their keys and they're looking under the street light because the light is better. You don't want to ask the questions that are easy to answer. You want to answer the questions that are important to your business. So you need to really figure out what are the questions that are important to your business. And I know if you're in business, you're all thinking about that. But don't go and answer a question just because it's an easy question to answer. And oftentimes the questions that are important for your business, sometimes they might be hard, but sometimes they might be easy. But if you're in the analytics business, always ask. I was listening to someone from Zynga Talk that runs analytics for Zynga Talk, and he said that one of the analysts in the group had gone and figured out what was the optimum time period to release games. If they released games too close, they cannibalized each other. If they released them too far apart, there was kind of a trough in between. So there's and he did a nice mathematical analysis of what was the distance between games that they should do their releases. And it was well done and it was theoretically sound. The thing is, it wasn't at all valuable to the Zynga business, because when they have teams of people that work on games, and when the game is, if they should release the game today, but it's got bugs in it, they can't. And if the game is ready, they don't put it on the shelf like a movie and wait for the Christmas season to come, because there's a team of people. They release it as soon as they can. So it was an interesting analysis, but it wasn't valuable to the business. So you should always be thinking about how you're going to use the answers to the questions to impact your business. You're not just looking for knowledge or insight or sort of general observations, but what action are you going to take based on that data to change your business? And I would say, I was listening to the talks this morning, and the question is why. You can always ask yourself, why are you doing something? And when I was doing this talk, a lot of times I was thinking about, I have to admit, I'm an engineer. So I was thinking about what do we do, how do we do it? That's what I wanted to convey to you guys. But if you step back a second, why is always to make money, because we're all in business. But how are we going to make money? Actually, in search, we're really in the business of mind reading. So if I want to kind of step up at a meta level, turning data into gold, new alchemy. So what is my job at eBay? I'm a mind reader. And I'm not very good at it, so I use a lot of technology to do it for me. But it's really a mind reader. When somebody comes to eBay and they type in BAPE, I need to know what they're looking for. And what are people looking for when they type in BAPE, right? I didn't even know what BAPE was. But we do the log mining, and it turns out that BAPE is an acronym for bathing ape, right? So some of the sellers will have bathing ape and BAPE in their titles because they want to pick up all the buyers. Some of the buyers might use one, some might use the other. The buyers and sellers on eBay, the terminology is not always the same, and different people don't always use the same terminology. So it's our job. I mean, basically, we're a matchmaker. That's what eBay does, right? We're a matchmaker. We take a slice off the top, like many of the rest of us in the technology business. And if you want to be a good matchmaker, you have to understand both sides. And I don't speak Polish, and we run our site in Poland, and Italy, and France, and everywhere else. eBay's a global company. So if I want to connect people in all those different countries, I have to do it from a technological standpoint, and that's by looking at the behavioral data. So always focus on the business, and doing this kind of data analysis oftentimes can accelerate your time to market and make your decisions data-driven and relatively quick, because you can go to the data and you can ask a question and get an answer, make a decision, test it, make the next decision, test it, make the next decision, test it. If you come to eBay today, you're in an experiment, guaranteed, right? We have many, many experiments running in parallel all the time. Most of the people in the industry call it A/B testing, but it's usually not A/B. A lot of times it's A, B, C, D, E, F, and there's lots of orthogonal tests running at the same time. So everybody's in some sort of a test. And for the business that I'm in, you won't even know it because it's usually changing synonyms and things like that. I wanted to give you a couple of stats about how quickly things have changed, just sort of the acceleration of change. eBay wasn't necessarily an early adopter of Hadoop. I'd say we're kind of, the tech companies are generally the early adopters. Yahoo was one of the big drivers for Hadoop. MapReduce, the original paper, was written at Google quite a few years ago. But we had a research cluster in 2007. 2009, we were doing a little bit more. We started building things out in 2010, doing more of this. And this year, we've quadrupled our capacity, and we're launching 2 big clusters. So there's 24 petabytes of data in each one of these. They're large. And they're already oversubscribed. So I already have engineers on my team complaining that it's too slow and there's too many people running jobs at the same time, and that we should have a priority scheme so that their jobs are more important and the other people should use the printer that's way down the hall. So it's kind of the same as many other things in technology. What are some of the trends? So some of the trends are, some things used to be more human editorially generated at eBay. Same with Yahoo. You know, when Yahoo started, it was sort of a human curated taxonomy of the web. Here are the interesting pages to look at. It doesn't scale very well. It doesn't scale to a lot of countries. And pretty soon that moved into search, right, and machine generated. Data sets have moved from being smaller to being larger. The sources of data have moved from being few to many. People now will have you'll have your own inventory. You'll have your user behavioral logs, all your web logs. You might scrape data from other sites. You might have catalog providers that provide information. Usually you're taking data from many different aggregate sources, and a lot of times you have to combine that. And then context, things are still moving towards personalization. We're not as far along the line in personalization as we will be in the future. But you're moving from sort of, in my business where I'm doing synonyms, acronyms, related searches, it's still mostly one size fits all. We apply the same synonyms typically to everybody. So if we're going to do an expansion from cowboy to cowboys, we'll do that synonym usually everywhere. But the context makes a difference. So if the last item a person looked at on eBay was in the Western wear category, then I probably don't want to do the expansion I don't want to do the stemming. I don't want to do the plural singular form of cowboy, because when I search for cowboy hats, if I do the expansion to cowboy or cowboys, I bring back the Dallas Cowboys. Same with van and vans. Typically singular plurals are good synonyms to do, good stemming. But in some contexts, they're not, right? So for van and vans, because Vans is a brand, that actually turns out to be not such a good thing to do. And this was just a bit of a summary. Here's the statistic for price per gigabyte. So focus on the impact for your business. Try and keep things simple if you can. It's easier to change things if they're simple. A lot of times in Hadoop, people will they'll bring in all their raw logs, they'll store the raw logs, they'll do a small level of processing to do some sessionization to store user sessions, so everybody doesn't have to reinvent the wheel every time they want to do user analysis. And they'll store those in a fairly straightforward format. Think about your data first and your questions later. Think about how you're going to collect this data, what you're going to keep, how you're going to less about how you're going to use it in the future because you're not sure, but just how you're going to store it so that it's flexible, so that it's available in the future, and store it. And now I was going to segue into search. And will you guys tell me when we start at 12:30, when it's 1? I want to make sure I leave time for questions. It's 1 already? 2 minutes? Okay. I'll talk a little bit about search. So it used to be the case that to build a search engine, you could focus on documents. And that's what information retrieval was all about. People did all this document analysis, and they looked at the documents, and then you would search, and the search would keep a gigantic reverse index of all the words in all the documents, find all the documents, and them or them together, and bring back the right documents. It was all about documents. So when information retrieval started, there weren't that many users. People did their searches in libraries and things like that. And that's changed a lot now. I changed this slide to include the people at the top, and I included dancing people because some people liked it. I listened to an interesting speaker talking about, let your users party on your data, which I thought was, I like the mental image of that. But your users are actually doing a lot, and they're telling you what words mean and how to get there, and what the different contexts are. And you can't build a good search engine anymore just by doing document analysis. You have to have users. Yandex is beating Google in the Cyrillic market, and the reason that they say that's the case is because they have all the Cyrillic users. So when I type in refrigerator in Moscow, I'm looking for a refrigerator. But when I type refrigerator in an outlying area, Cyrillic-speaking area, I'm not looking for a refrigerator, I'm looking for refrigerator parts. And they know that not because of any document analysis, but because that's where their users are going, and that's what they're doing. So these are some examples of sort of some of the synonyms that we'll learn automatically. And some of them are simpler, and some of them are a little bit harder. Handbag and purse certainly makes sense. Texas Instruments, you can figure out automatically what the acronyms are. Lenovo and ThinkPad, you can figure out, you don't have to know that one company bought the other or that a company was sold. You can just see people entering the queries and clicking on the same item. So if two people enter the same query, two people enter different queries, but they click on the same item, those queries are probably related. So there's a lot of kind of graph, sort of bipartite graph analysis that people do. So this is one set of examples. And then I was talking a little bit about context and specificity. We used to do bidirectional synonyms. So we'd say, oh, foo and bar are synonyms. Handbag and purse are synonyms. Whenever we see one, we should do the other. We would make them bidirectional and do them all different ways, transitivity for the synonyms. But many of these things are different in different contexts. So you need to know what was the context of the query. So ATC is an acronym, but it means different things in different places. So it could mean armored troop carrier, artist trading card, or automatic tool change, but it depends on what the context of the query was. And specificity makes a big difference. Oftentimes you can go from general to include more specific things. So if I did a query for blue, it might be safe to include teal items. But if I did a query for teal, it's definitely not appropriate to bring in all the blue items. So some of these things, this is just in the search business, make a difference. And so the final, this is kind of the wrap-up slide, is just save your data. The aggregate analysis is kind of the tip of the iceberg. There's a lot of value in the rest of the iceberg there. Analyze your data, and then test. You should, I'm assuming that most of you do, but I'm not sure. You should have an infrastructure set up so that you can A/B test, right? So get the data in, come up with a new data set, test it versus the old, and measure the impact in your business. Recently, we did a project for compound words in Germany. The Germans like to string a lot of words together and make gigantic, big, long words. And we don't really care about all the gigantic, big, long words you can make. In fact, it's kind of an unlimited number because they can arbitrarily smash words together. I'm not German, so I'm not a real expert in that. We only care about the ones that people use on eBay. And that was many millions of dollars in incremental revenue per year. We A/B tested that, and we could see the difference, right? We could see the uplift from the group of people that didn't have the expanded compound word list and the people that did. And for us, we have a fairly high volume website in Germany. It was millions and millions of dollars in annual revenue. But if you don't test those things, you don't know how much. You think it was better, but you don't know how much better. So you should be able to, and if you don't measure things, it's hard to manage them. So you should always strive to be able to test these things. And that was it. I'm going to wrap up because I wanted to make sure I left time for questions. And there's a microphone in the back, so just go ahead and raise your hand or stand up, and he'll bring it by. Right here.
Excuse me. I have a question specifically for web analytics. And tools like Omniture and Google Analytics come with a huge amount of pre-canned reports.
Right.
And you mentioned that the value would be in finding unknown pieces of information. Yet I also find that a lot of metrics have a natural random nature to them or natural variability. Right. So do you have any tips on how to actually find if a change is significant or whether it's still part of a sort of general random process?
Right. Well, many times at eBay we do a lot of our own analytics. So when we're doing our A/B testing, we're always looking for statistical significance, right? So you can oftentimes use sort of standard, p-value statistical significance test to see whether variability is random or not. So if you're using an analytics package, and I don't typically use these analytic packages, I would expect that they would have that built into them. I'm not sure. Oftentimes when you do an A/B test, or somebody gives you a graph and says that here was your A test and here was your B test, and it's taller, what you really want is error bars on those bars, right? You really want the error bars because you want to know how much was random chance. It's actually quite difficult, even at a large-scale website, to measure very small differences. You know, when I came to eBay, I had done experiments when I was a graduate student many years ago, and I had to pay users, and it was hard to collect up users, and you had small sample sets. So when I came, at a bigger company, I think, oh, well, I should be able to get statistically significant results in 10 minutes on eBay, right? I should just put it out, and millions of people come through, and I'll have statistically significant results immediately. It's actually not quite that easy. One of the big reasons why it's not easy at eBay is the price differentials are quite large. So if you have one group of users, and I think the current price record at eBay is $35 million for a Learjet. So if the Learjet ends up in one of, if somebody buys one of those and it ends up in one half of your test and not in the other half of the test, it skews that. If you were just looking at average sale price, just somebody bought that one jet, all of a sudden, the one side looks great. So there's a lot of variability, so you definitely have to look at variability. I don't know if I totally answered your question, but...
For your analytics, how much of the machine learning algorithms, and do you do a lot of machine learning on top of your Hadoop data, or directly do standard analytics?
We do, yeah, we do. So I'm part of the search science organization. So we have a ranking group, and that's based on machine learning, and we build decision trees based off all the factors. So from a search standpoint, kind of a standard flow would be, you figure out what you think are the interesting variables. So for example, I'm going to stick to synonyms because that's what my team does. So if I'm looking for synonyms, you might think, oh, handbag and purse. What are the statistics that you would have associated with handbag and purse? It's just one word. Well, actually, there's quite a lot. I can look at handbag and purse, and I can look at the category distribution across eBay when I do a search for that term. And so we do KL divergence. If you're a machine learning person, we look at the distribution of categories for those two words and how similar those two distributions are. Then we do the same KL divergence for price. We look at the price distribution and see how close it is. If either the category distribution or the price distribution is quite large, then they probably aren't synonyms from a machine learning standpoint. And then we pull out a bunch of other factors with, how often, if we expand a query, do people click through or not click through. We compute a whole bunch of factors, and then oftentimes we'll do some human judgment, crowdsourcing. Crowdsourcing is also a pretty valuable tool for many things. And then we'll feed all that back into a machine learned supervised classification. And then learn. So we'll generate 1 million synonym candidates, and then we'll use a machine learned classifier to prune out the false positives and only push the good ones to the site if you're sort of more into the techie side. But for those of you who aren't into machine learning or logistic regression or all this kind of mathy stuff, it's really counting, right? You're just counting. How many people went the way you wanted versus went the way you didn't want? And, it's counting. So.
You talked about using price as one of your determining factors in category.
Right.
What are some of the other factors that you use to determine if something's a synonym is a good example, but in our case is whether or not a sale worked.
Right. Well, so there's kind of I had a couple of backup slides. This is kind of our online infrastructure. Backup slides for sort of a lot of the types of things we do, but a lot of times what people do is they end up building different kinds of graphs. And so you'll hear people say bipartite graph. It's just a fancy way of saying a graph with two sides. You got the side of the things you know and the side of the things you want oftentimes. So for synonyms, it might be, I'm going to talk about related searches for a second. I'm going to build a two-part graph where one side is going to be queries and the other side is going to be eBay items. And if I'm going to run through all the queries on the site, and for every query, I'm going to draw a line to all the items that the person clicked on. And now when I'm done with that, I'm going to go back and I'm going to find an item, and I'm going to find all the queries that came into that item. And I'm going to say, well, if people issued queries and they clicked and looked at this item, then they must have liked that item based on the intent, right, reading their mind for their query. So those queries might be related. And I'm going to look at how related they are by how often it happens. So if I had, 2 queries with, 1,000 edges, with 1,000 clicks to the same item, and then all the other queries were kind of real small content, I might say those 2 queries look like good related searches. So that's kind of one way of doing that. That's sort of the query item bipartite graph there at the top. And then another thing is query transition. So if somebody entered a query, Nike shirt L, and then they changed it and it was Nike shirt large, I'm going to say, oh, L and large. That was a substitution in successive queries that might have been a synonym. Now, it could have been that they looked for a red Nike shirt and a blue Nike shirt, which would be the same exact pattern. But it's just, if you have many different factors, then when you go from a machine learn standpoint, you can blend them together, right? You have many different sources of information. You don't just have one. So did that answer your question? Oh, okay. Do you want to ask the second part again?
Well, you answered it as your answer was, if these 2 queries get clicked on, that's what I'm looking for is clicks.
Yeah.
There's also, you can look in dollars sold, or you could look in something
Purchases.
else.
Yeah.
What are some of the factors you use like that? What are results? I mean, is it total clicks, total sales, total? Yeah.
So I think your question, I'm going to answer it in the context of ranking. So on eBay, 2/3 of the searches are best match. And then the rest are time or price. But for ranking, we want to decide, what are the factors that are important? Well, certainly one of them is the seller's prior reputation, right? If the seller typically sells through their inventory, it's probably an indication that they have good inventory and good prices. That's one. We keep track of all the impressions on the site, so sales over impressions is a really important factor. So if many people sell multi-quantity items on eBay, so if you have multi-quantity fixed price items, in the number of sales you get over the number of times that people see your item is relatively high, that's a really good indication that you've got a high quality item. It's sell-through, right? If it's selling through fast, then it's an indication it's good. Now, if somebody lists an item on the site and we've shown it a couple of thousand times and nobody's bought it, or maybe nobody's even clicked on it, right? You could do clicks over impressions also. If nobody's clicking on it, nobody's buying it, it's an indication that it's either being returned when it shouldn't be returned. Maybe the seller's spamming in their title, or maybe it's not priced. Maybe it's not priced to move, right? Maybe there's a lot of other inventory on the page that's similar, and they've got the worst priced item, and it's never going to sell. So those are a couple of additional factors. But there's a lot of factors like that. When an item comes on the site of eBay, we guess whether it's going to sell, and we guess how much it's going to sell, even if it's an auction, by looking at similar sales in the past.
You mentioned that you take your data and you feed it into a machine learning system. Is there a Hadoop type platform for machine learning? What platforms do you use to feed that data into,
people
if
use
any?
A lot of different tools. Specifically at eBay for ranking, we use a tool called TreeNet to build decision trees. But there's some open source systems. There's one called Weka that you can run on top of Hadoop. There's a bunch of different.
Sorry, what was it?
WEKA. So there's a few different packages. They tend to be. The people in that business tend to be fairly specific. I'm in an applied research area, so our goal is business impact, but I'm typically hiring a lot of times masters and a lot of PhDs. So yes. Yeah, I can't say that I'm an expert in everything. At some point, you can't be an expert in everything, but somebody's an expert in each thing. Right? Good question.
Time's up now, I'm afraid.
Okay, great. I'll be here or out in the hall if people have additional questions afterwards. Thank you very much for coming. Appreciate it.